Hi students, here we are going to solve the problem. If alpha, beta are zeros of the quadratic polynomial p of x is equal to 3x square minus 4x plus 1, find the value of alpha cube beta plus beta cube alpha, right? So if you consider the zeros as alpha and beta, then we have to find the value of the given expression. First we will find the zeros of the given polynomial. So given polynomial is 3x square minus 4x plus 1, right? So here the product should be the coefficient of x square and the constant, right? So the product is 3, the sum is minus 4. So which one will satisfy for the product of the 3 is 1 into 3, only 1 into 3 is the possible, right? The factor of 3 is 1 into 3. So if you subtract the if you add the negatives of the both, you will get, right, minus 1 comma minus 3. So minus 1 into minus 3 is plus 3, minus 1 plus minus 3 is minus 4. So now the middle term can be split and write in the terms of minus 1x and minus 3x. So this I will rewrite as a 3x cube minus 3x minus 1x plus 1. So from the first two term, the common factor is 3x. So 3x into the remaining here is 3, here nothing is remaining, so it is 1. And in the balance two term, the common term is 1. Let me take minus 1. So the next term will be get the same. So minus 1, so it will become a plus x, and minus 1 will become a minus 1, right? So now the common term is x minus 1, right? If you took a positive one as a common factor in this both the term, it will become a minus x plus 1. So I took as a minus 1 as the common, so the sign will change, so this both the term will looks same. So now the common factor is x minus 1, and here the remaining is 3x, and here the remaining is minus 1, right? So either this should be 0 or this should be 0 to get the zeros of this polynomial, right? So let me consider x minus 1 is equal to 0. So x is equal to 1. Let me consider this alpha is equal to 1. So next I consider this 3x minus 1 is equal to 0. So x is equal to 1 by 3. So beta will become 1 by 3. So now we know what is the value of alpha and what is the value of beta. So this we have to substitute in the expression, right? What expression is given? Alpha cube beta plus beta cube alpha. So before you are going to directly substitute here, we can simplify, right? We can take a common factors, right? What is the common factor here? Here is the alpha and beta, right? This we can write it as an alpha into beta. The here remaining is alpha square plus here beta square, right? Alpha and beta are the common. From first term alpha and beta, the remaining is an alpha square because it's alpha cube, and the second term it's a beta cube. One beta common factor we took outside, so the balance is beta square. Clear? Now we substitute, then it will be easy to simplify. So alpha value is 1, beta is 1 by 3. Here the alpha square is 1 square is 1 plus the beta square is 1 by 3. 1 by 3 square is 1 by 9. I directly substitute here, right? Beta square, the beta is 1 by 3, but if the beta square, so that's why I written as a square term. The 3 square is 9. So 1 into 1 by 3 is an 1 by 3, and if you take 9 LCM, it will become a 9 plus 1 by 9. So the 9 plus 1 is 10. 10 into 1 is 10 by 9 3s are 27. Sorry, right? So 9 plus 1 is 10, 10 into 1 is 10, 9 3s are 27. Clear? So first find the zeros and substitute in the given expression. If it is able to simplify the expression, you simplify and substitute, so it will take a less steps. Otherwise it will take a little more time. This will be a time consume. Here we go for the next problem. If alpha and beta are the zeros of the quadratic polynomial p of s is equal to 3s square minus 6s plus 4, find the values of alpha by beta plus beta by alpha plus 2 into 1 by alpha plus 1 by beta plus to alpha beta. So first we have to find the zeros, right? So the given expression, the p of s is what here? 3s square minus 6s plus 4. I think we can't find directly by the splitting method, right? Here the 4 3s are 12, the product is a 12, and the sum should be a minus 6, right? Is it possible? The factor of 12 is 1 into 12, 2 into 6, 3 into 4. So even you add or subtract, whatever you do, you will never get a sum 6, right? So this method will not work. Then how to do this problem? Yes, we already learned about the relationship between zeros and the coefficient, right? Here we have the coefficient. So here we link this coefficient to the zeros. So do you remember that? The sum of the zeros is minus b by a, right? So here the consider the zeros are alpha and beta. So alpha plus beta will be minus b by a. Clear? Do you remember it? Yes. So if it is not possible to find a zero by this middle term splitting method, we can use the relationship between zeros and coefficient, because we'll have a coefficient from we can get a coefficient from the given expression, right? Here the what is the b value here? Minus 6, right? So minus of minus 6 divided by a is a 3. So it will become a minus into minus is plus, 6 by 3 is 2, right? The value is 2. Clear? The b value is minus 6. So minus into minus is a plus, and 6 by 3 is 2. So next, multiples. Alpha into beta is equal to c by a. So what is c here? The constant 4. 4 divided by a, 3. 4 by 3 will be the same, 4 by 3. Now we have to, we know what the sum of the zeros and multiples of the zeros, right? So it is alpha plus beta, it is 2. Alpha into beta, it is a 4 by 3. So what is the given expression? I will write this expression here. Alpha by beta plus beta by alpha plus 2 into 1 by alpha plus 1 by beta plus 3 alpha beta. So if you here see, we have a multiples of alpha and beta, but rest is we don't know the alpha and beta value, right? So we have to rewrite the given expression into the sum of the zeros, sum of alpha and beta, or multiples of alpha and beta. We have to try to rewrite it. Yes, it's possible to rewrite. Let's see one by one. So just simply by taking an LCM of the both alpha and beta, right? It will become an alpha square, it will become a beta. So here it will become alpha into alpha, here it will be beta into beta. So it will become an alpha square plus beta square divided by alpha beta. Now you see in the denominator it become a alpha into beta product, plus second term 2 into, so here also we can take an LCM, it will become an beta plus alpha by alpha beta, right? Here you get the sum on the numerator and multiples on the denominator. We can directly substitute here. We'll substitute later. First we will change the entire expression into the sum and multiples of the alpha beta. So here it's a multiples, here is a multiple, here is a multiple, and here is a sum. But this term alone, it's like an alpha square plus beta square. Is it possible to change? Yes. Do you remember the identities that you learned? A plus b the whole square is equal to a square plus b square plus 2ab, right? You can see it is like an a square plus b square, right? So rest is like in a sum on the product. Let me bring this side. It will become an a plus b the whole square minus 2ab is equal to a square plus b square, right? So instead of a square plus b square, we can use this identities, which is only we have a sum and product, right? So this we rewrite as alpha plus beta the whole square minus 2 alpha beta whole divided by alpha beta, right? On x for this alpha square plus beta square, instead of that we are using this identity and we express in the terms of sum and multiples. So now everything is in the terms of sum and multiples, right? Now you substitute that. So if it is some alpha plus beta, it is a 2. If alpha into beta is a 4 by 3. Let me substitute. Alpha plus beta is a 2. Here the square is, it's a 2 square minus, what is here, 2 into, what is alpha into beta? Do you remember alpha into beta? 4 by 3. 2 into 4 by 3. Whole divided by alpha into beta is 4 by 3. Plus 2 into alpha plus beta is a 2. Alpha into beta is 4 by 3. Next plus 3 into alpha into beta is 4 by 3. Now we will simplify. That's it. We will get an answer. So 2 square is a 4, right? 4 minus 4 2 is a 8. 8 by 3 whole divided by 4 by 3 plus 2 into this we can rewrite as in the reciprocal, 2 into 3 by 4, right? Plus here the 3 and 3 get cancelled, 4. Clear? Here 4 also 1 times, 2 times, again the 2 and 2 will get cancelled, we will get a 3. So what happened to here? Here we have to take an LCM, right? So LCM is a 3, 4 3s are 12. So 12 minus 8 divided by 3, the whole divided by 4 by 3, plus here 3 plus 4, right? So 12 minus 8 by 3 is, 12 minus 8 is 4. So 4 by 3, the whole divided by 4 by 3 plus 3 plus 4. So 4 by 3 1 times, we will have a 1 plus 3 plus 4, which is equal to 8. Clear? So from this problem we know if it is not able to find any zeros using the middle term splitting method, you can compare with the relations between coefficients and the zeros and try to change the given expression entire term into the sum of the two zeros and the multiples of two zeros, whether the given will be not like that, right? But we can use some identities or taking LCM, we will get. Clear? Thank you.